Good day everybody. We got a beautiful integral e raised to the power of cos inverse of x times dx. This is an MIT integration B question. So foremost, what I wish to do is I would like to make a u substitution. So let me take u to be equal to cos inverse of x. I can move cos inverse to the left. That would give me cos u is equal to x, and differentiating both sides, I would get negative sine times u times du is equal to dx. So this integral can be rewritten as integral e raised to the power of cos inverse of x is going to be u, and dx is going to be negative sine u times du. So we are expected to integrate this quantity. Now what I wish to do is I would like to foremost consider this quantity alone without the negative sign. Consider, or in other words, okay, let me start off with consider. Consider e raised to the power of u times sine u du, and let me take that to be equal to I, right? So instead of saying consider, I can use the word let us consider I to be equal to this. And then what I wish to do is I would like to utilize integration by parts. So for that I would perform the differentiation on the left hand side and integration on the right hand side. So on the left hand side you take the value of u, so I would be taking sine u. On the right hand side you take the value for dv, or e raised to the power of u times du, right? So this would be the integration column. So you differentiate sine u, you get cos u. You integrate e raised to the power of u, you get e raised to the power of u. You differentiate cos u, you get negative sine u. You integrate e raised to the power of u, you get e raised to the power of u. Now the signs are to be placed. So the signs would start with positive, negative and positive. When you are writing, you have to write it in this fashion: sine u times e raised to the power of u, cos u followed by a negative sign, and cos u times e raised to the power of u, and finally positive times this quantity has to be integrated, right? So how are we going to write? I'm going to represent this on the left hand side. So you can either say I equal to, because you know that I is integral e raised to the power of u sine u du. So that is equal to this into this. So let me write it like this: e raised to the power of u times sine u, first quantity, followed by a negative sign, times cos u into e raised to the power of u. So e raised to the power of u times cos u, this is the second quantity. And the last quantity is actually negative times, you need to integrate this, e raised to the power of u sine u times du. So this is equal to e raised to the power of u sine u negative e raised to the power of u cos u, but this is nothing but my I, right? So I place a negative I, so I move this negative I to the other side, and that would be I positive I is equal to e raised to the power of u sine u negative e raised to the power of u cos u. So therefore you get 2 times I is equal to e raised to the power of u sine u negative e raised to the power of u cos u. But you need only I, so I is equal to 1 over 2 times e raised to the power of u sine u negative 1 over 2 times e raised to the power of u cos u. So this is what? This is nothing but integral e raised to the power of u sine u du. This is the value that we have got. Now we need to take this value and substitute it here, right? So I'm taking this value and I'm substituting it here. So there is a presence of a negative sign, so that would give me, this will become positive, negative times negative will become positive. So that's going to be 1 over 2 times e raised to the power of u cos u. That will be the first value. Negative times positive, that will become negative. So 1 over 2 times e raised to the power of u times sine u, right? But what is my, let me use this space over here. Now what is my u? My u is cos inverse of x, right? So substitute it over here. So if you were to take this as 3, Therefore 3 can be rewritten as, this is equal to 1 over 2 times e raised to the power of u is cos inverse, so place cos inverse of x times cos of my u is cos inverse of x followed by negative 1 over 2 times e raised to the power of cos inverse of x times, this is sine, so sine u is cos inverse of x, cos inverse of x. Now I just want to perform some simplification. Now cos and cos inverse of x, this would give me just x there, so you can write that as x times e raised to the power of cos inverse of x negative. Now actually what you can do is you can take 1 over 2 out, because you have 1 over 2, 1 over 2. So in fact you can also take e raised to the power of cos inverse. So let me do it in the next step. Now I am interested in evaluating this quantity, sine of cos inverse of x. Now what is cos inverse of x? Since we have taken u to be equal to cos inverse of x, so this would mean cos of u is equal to x, and this is nothing but x over 1. Now if you were to use the Pythagorean right triangle and the trigonometric ratio, if I were to take this as u, this side is opposite, this side is adjacent, this side is hypotenuse. So this is going to be x, and the value of 1 is going to be on the hypotenuse side. And if I were to take this as a, b, c, I want to get the value for the opposite side. So ab squared plus bc squared is equal to ac squared. This ab squared is x squared, bc squared has to be found, and ac squared is 1 squared, that's going to be 1. So bc squared is equal to 1 negative x squared, so bc is equal to root of 1 negative x squared. So this is root of 1 negative x squared, and this is u. What is u? Cos inverse of x. So this is actually sine u. And what can I write for sine u? Sine u is nothing but opposite side by hypotenuse 1, which is nothing but root of 1 negative x squared, right? So wherever you see sine of cos inverse of x, you can substitute root of 1 negative x squared. So this is going to be 1 over 2 I have already taken out, so this is e raised to the power of cos inverse of x times root of 1 negative x squared. I would like to take cos e raised to the power of cos inverse of x out, so I can write this as e raised to the power of cos inverse of x, there is a 2 there, divided by 2 times, I got a x negative root of 1 negative x squared plus arbitrary constancy. So this is the solution for this beautiful question, integral e raised to the power of cos inverse of x times dx. Thank you everybody, enjoy your day.